Hello and welcome to this screencast on the cross product. Now the cross product of two vectors a and b is denoted by this a cross b. So it looks like a time symbol, like a multiplication symbol, but it actually means something very different. Now cross product is formally defined as the magnitude of a multiplied by the magnitude of b multiplied by the sine of the angle between them. So similar to the similar to the dot product, but in this case, this is a sine instead of a cosine. Now, what does the cross product mean? Now, if I have any two vectors, a and b, okay, the cross product actually gives us a vector which is perpendicular to both a and b. Now, by perpendicular, I mean it's at right angles to vector a, and it's also at right angles to vector b. Okay. Now, unfortunately, the cross product is not entirely a straightforward calculation. So what I'm going to do is I'm just going to show you how to calculate cross product between two general vectors. Okay, so I'm just going to define a general vector A as being a 3-tuple A1, A2, and A3. Okay, and vector B in a similar fashion. B1, B2, and B3. Now, a cross product is what we call a determinant, and it's the determinant of a 3 by 3 matrix, where the top row are the basis vectors I, j, and k. The second row will be the vector A, so A1, A2, and A3, and the third row is a vector B1. Vector B with B1, B2, and B3. Okay, there are a number of ways to calculate this determinant. I'm going to show you a way which is called Cyrus's rule. And this is a way I think is one of the most simplest way. What we do is we take the first two columns of this 3 by 3 matrix here and we repeat them just to the right of our matrix. So the first column is I, A1 and B1, and the second column is J, A2 and B2. Okay, now what we do here is we draw some diagonal lines. So starting at the first element in the top row, I draw a diagonal line which goes down and to the right. So starting at I, it goes through A2 and B3. And I do the same with J, and I do the same with K. Okay, so what I've done that for is we actually multiply the elements along each of those diagonal lines. So first off, I have I multiplied by A2 and B3. And to that, I add the second one. So the second one starts at J. Make it neat. And J is multiplied by A3 and B1. And to that, I add the one which starts at K. So K goes through A1 and B2. So that's K, A1, and B2. Okay, that's half of it done. I'm not quite finished yet. What I also have to do is draw another set of diagonal lines, but this time going from the first element in the bottom row and up and to the right. Okay, so starting at B1, it goes through A2 and through K, and I do the same starting at B2 and the same starting at B3. Okay, this time instead of adding them, I subtract them. So here I'll start off with K times A2 times B1. So K times A2 times B1 subtracted I times A3 times B2. So I times A3 times B2. And finally we have J, which is multiplied by A1 and B3. So minus J multiplied by A1 and B3. Okay, what I'm going to do now is just simplify that somewhat. So let's collect some like terms. What have I got in terms of I? So I've got A2 and B3. Oh, don't know what that is. B3. And that's subtracted, so from that we subtract A3 times B2. Okay, so that's the I's done. Now move on to the J. So what have we got? We've got A3 and B1. And from that we subtract A1, B3. Oh, A1, not AI, and B3. And finally, we've got a vector K, and that's A1, B2. And from that we subtract A2, B1. Okay, so that is, in general terms, how we calculate the cross product of two vectors. It's a lot easier when we start including numbers instead of A1s and B1s, etc. So I'm going to have a look at an example. So I'm going to find a cross product between two vectors. Let's call my vector A. Let's call that 1, 2, and 2. And my vector B, I'm going to call 4, minus 5, and 7. So these are two vectors. They're three tuples, so they're vectors in three-dimensional space. What is the cross product between these two vectors? Okay, so A cross B. This is an example. Okay, A cross B. So we form that 3 by 3 matrix. So remember the top row are the vectors I, J, and K. Okay. Second row is vector A, and the third row is my vector B. Okay, so using Cyrus's rule, remember we repeat the first two columns just to the right. So IJ, 1, 2, and 4, and minus 5. Okay, so remember, we draw 3 diagonal lines, so starting from I, down into the right, J, down into the right, and K, down into the right. Okay, so we have I times 2 times 7, which is 14. Okay, actually, I'm going to write that in a different way. I'm just going to write the 14 in front of the I. So 14 I. We have J times 2 times 4, which is 8. So 8 times J. And we have K times 1 times minus 5, so that's minus 5K. Okay, so that's the first step done. Second step is we do the upward diagonals. Okay, so upward diagonals, and remember we subtract these. So first one is K times 2 times 4, which is minus 8K. Second one is I times 2 times minus 5. Now, because remember we're subtracting the ones going up, but this will work out as minus 10I. So minus 10I is plus 10I. And finally, we have J times 1 times 7, so that's minus 7J. Okay, so let's see what we got when we combine all of those together. So look at the i's first. I have 14I here, and I have plus 10I here, so that's 24I. And I have 8J here, and I have minus 7J there, so 8 minus 7 is 1, so that's just plus J. And finally with the K's, I have minus 5K, minus 8K, so that's minus 13K. Okay, that's in basis vector notation. I prefer them in 3 tuples, so I can write that as 24, 1, and minus 15. So that is the cross product between those two vectors, A and B. Okay, so we're happy now we can calculate the cross product of two vectors.